This is the second part of section 3.7, graphing absolute value equations. I'm going to start with a vocabulary term, and it's also some notation. Vertex form. Whoops, that should be a pen. Vertex form. Didn't mean to slide everything there. Vertex form. Now, it doesn't have a definition, but what vertex form looks like is this. It's g of x, or f of x, or whatever letter you want to use for function notation. G of x is equal to a times the absolute value of x minus h plus k. That's not and k. Let's try that again. Plus k. All right, now, the reason it's called vertex form, and like I've said in the past, math people are not creative, okay? It's called vertex form because the equation or the function tells us where the vertex is. So the vertex is at, and it's an ordered pair. The ordered pair is, whoops, not k, sorry, h and then k. Okay, the vertex is at hk. Now what I want you to notice is that these h's are opposites. This one is negative h, this one is positive h. Okay, so I want to make that clear. These are opposites. Okay, opposites. So if this is minus 2 on the inside, the x-coordinate of the vertex is positive 2. Or if this was x plus 3, then the vertex would be at negative 3. Okay, the y value of your vertex, k's, notice that this is positive k, this is also positive k. With the y value, the values are the same. So if it's plus 2 out here, it's positive 2 down here. Okay, so vertex form, the vertex is at hk, the h's are opposite from function to point, the k's are the same. Positive, positive, or negative, negative. All right, let's try a few here. Number 1, graph the function. Let me get rid of this little mark here. F of x is equal to the absolute value of x plus 2 minus 3. Now this is in vertex form, okay? So we can say the vertex is at, now it comes from these 2 points, and I'll do a different color here. The y value of my vertex is the number on the end of my function, and it's that number, negative 3. Okay, the vertex is at negative 3. Now the x value, we'll do that in orange here. The x value, it's going to be the number, but we need to check the sign. This is positive 2, and to go to the vertex, we need to switch the sign. So it's going to be negative 2. So the vertex is at negative 2, negative 3. Okay, so now we can come up with some ordered pairs. X, Y, 1, 2, 3, 4. I put the vertex in the middle, negative 2, negative 3. That way we can just see that nice symmetry in our table and on the graph. So negative 3 and negative 4. How do we find these y values, or these y values? We plug the x values into our function right here, and we see what we get. Okay, so let's start with the x value of 0. We'll just start here. So 0 plus 2 is 2. The absolute value of 2 is still 2, and then 2 minus 3 gives me a negative 1. Okay, do the same thing with negative 1. Negative 1 plus 2 is 1. The absolute value of 1 is still 1, and then 1 minus 3 is negative 2. Now, if we keep going, negative 3 plus 2 is negative 1. The absolute value of negative 1 is positive 1, and then 1 minus 3 is negative 2 again. And then I hope you can see that this one is going to be negative 1 under the x value of negative 4. Okay, so once we've got our xy table, we can kind of sketch the graph here. I'm actually going to draw. I'm bringing some graph paper here. And let's get rid of this line. Let's try again. Let's make this look a little nicer here. Okay, so we got our coordinate plane. We can plot our points. So we've got negative 2, negative 3 is right there. Negative 3, negative 2 is there. Negative 4, negative 1 is there. And we got that one, and we've got that one. And we can draw our picture. Okay, so there's the graph of number 1, f of x. And we can, if you want, you can write f of x off to the side. Okay, so x plus 2, absolute value of x plus 2 minus 3, that would be the graph right there. All right, let's move on. Number 2, g of x is equal to the absolute value of 2x plus 2 minus 3. Now, this number in front of x, okay, I'm going to make a little note of this. The number in front of x, number in front of x represents And remember, from the transformation section, if we're multiplying x by something, that would be a horizontal, and it's going to be a stretch or a shrink. Okay, the rules still apply. If what we're multiplying x by is a big number, remember it's the factor is the reciprocal. Okay, so if this is we're multiplying x by 2, that means the factor is 1/2, which makes this a horizontal shrink. Okay, so I'm gonna make a little note of that. This is a horizontal shrink. Horizontal shrink by a factor of 1/2. Now, I know that because I'm multiplying x by 2, and remember, horizontal things are always backwards in some way. So if we're multiplying x by 2, that means the factor is 1/2, and if the factor is 1/2, that makes it a shrink. Okay? So what this really means is that every point on the graph, because really this is basically, if I take away this 2, this is the same function that we just graphed. Okay, this is example number 1 without the 2, or with a 2 actually. Okay, so what this really tells me is that every point cuts the distance to the y-axis in half. Okay, so really what we need to think about is we're going to take this graph here and we're going to just shove everything this direction. We're going to make everything get closer to the y-axis. Okay, so now if we think about this, if the original vertex was at the point -2, -3. We can get that from this one right here, -2, -3. This distance right here is 2 units away. Okay, and if we're going to cut that in half, half of 2 is 1. Okay, so our new vertex is going to be at -1, -3. We're cutting the distance to the y-axis in half. Okay, this is important because we need the original, and then we're going to cut it in half, and it's now going to be -1, -3. Okay, so if we want, we could make our new xy table. X, y, 1, 2, 3, 4. -1, -3 is our new vertex, and then we can come up with other points. So 0, 1, -2, -3. And I'm going to rewrite the function here. That was the absolute value of, whoops, let's try that again. 2x minus 2, that's bracket, and sorry, plus 2, and then minus 3. Okay, so to find the y values again, we just need to plug in these x values. Okay, so if we plug in 0, 2 times 0 is 0, plus 2 is 2. The absolute value of that is 2, minus 3 is -1. Okay, do the same thing with 1. 2 times 1 is 2, plus 2 more gives me 4. The absolute value of 4 is 4, and then 4 minus 3 is 1. Okay, do the same thing with -2. 2 times -2 is -4. -4 plus 2 is -2. The absolute value of -2 is 2, and then 2 minus 3 is -1. Okay, do the same thing with -3. 2 times -3 is -6. -6 plus 2 is -4. The absolute value of -4 is 4, and then 4 minus 3 is +1. Okay, so we can go ahead and bring in our graph paper here. We'll draw our XY plane. Let's try that one again. Okay, and we can put our points in there. -1, -3 is there. That's the vertex. 0, -1 is there. 1, 1 is there. 2, let's see, -2, -1 is right there. And -3, +1 is right there. So you can see that our original graph, if we flip back, now we've shifted or shoved everything closer to the y-axis, both coming from this direction and that direction. Okay, so if we flip back, you can see that everything's just been kind of given a shove back towards the y-axis. And we'll keep working with this, so hopefully some of that made sense, and we'll try to solidify this a little more. Let's try another one here. Number 3, f of x is equal to the absolute value of x plus 2 plus 2. There's no number in front of x, so we don't need to worry about any horizontal shrinking. Okay, so we can just start by identifying the vertex. Okay, the vertex here is, well, the y value is the one on the end, so that's positive 2. The x value is the one in the middle, but it's the opposite, so it's going to be negative 2, positive 2. Okay, so we have our vertex, negative 2, 2, and when I make my xy table, xy, 1, 2, 3, 4, negative 2, positive 2, the vertex goes in the middle. Okay, so then you can just pick some x values around it, negative 1, 0, negative 3, negative 4. Those are usually the ones I pick, 2 above and 2 below. And then we need to find these y's by plugging it back in for x. Okay, so we'll start with 0. 0 plus 2 is 2. The absolute value of 2 is still 2, and then 2 plus 2 is 4. Okay, do the same thing with negative 1. Negative 1 plus 2 is 1. The absolute value of 1 is 1, and then 1 plus 2 gives me 3. Do the same thing with the other ones. Negative 3 plus 2 is negative 1. The absolute value of that is 1, and then 1 plus 2 is 3. And then if you do negative 4, what you're going to get is 4. So you can see that nice symmetry or pattern in your table. Okay, so let's bring in some graph paper here. And we need to graph this. Whoops. Okay. And we can plot some points here. So we got negative 2, positive 2 is there. Negative 1, 3 is right there. 0, 4. Negative 3, 3. And negative 4, 4 is right there. And we can graph the function. This is f of x. All right, let's try another one here. Let's kind of build off of this one. Kind of going back to that horizontal stretch or shrink actually here. So g of x is equal to negative 4x, the absolute value of negative 4x plus 2 plus 2. So now, if we didn't have the negative 4, if we just had this, that would be the same as the last one. So now we're multiplying x by negative 4. Okay, so we multiply x by negative 4. Okay, the question then becomes, what's the transformation? What's the transformation? Okay, what happens? Well, in the last one, we multiplied x by 2, and that was a horizontal shrink by a factor of 1/2. Well, here, if we think about just the 4 tells us it's a horizontal shrink, again, because the factor is the reciprocal of what we're multiplying x by, and that would be 1/4. Okay, so that takes care of the 4. What about this negative? What about this negative? What does that do? If we multiply x by a negative, what I hope you remember is that is a reflection. Anytime we're multiplying by a negative, that's going to be a reflection. And this time, it's a horizontal reflection, so if we look at a graph, we're thinking this way. It's a horizontal reflection. And what line do I cross when I horizontally reflect? That would be the y-axis. Okay, so this is a reflection in the y-axis. Okay, so let's think about this. The original vertex was where? Let's go back and look. The original vertex was at negative 2, positive 2. Okay? The new vertex, let's see. The y value is not going to change. We're not moving it up or down, so the y value is still going to be 2. So now we're going to think about the horizontal shrink by a factor of 1/4 and a reflection. Okay, so this distance right here is 2 units. Okay, so if I take that and divide it by 4, or multiply by 1/4, 2 divided by 4 is 1/2. Okay, so now instead of being at negative 2, I'm going to be at negative 1/2. That takes care of the shrink. Now I need to reflect it, so it's actually going to be at positive 1/2. Okay, so my new vertex is going to be at positive 1/2, positive 2. Okay, so now, once I've identified this vertex, let's go ahead and make our xy table. xy, 1, 2, 3, 4. We're going to have 1/2, 2 here, and I'm just going to choose whole numbers. 1, 2, 0, negative 1. Okay, so we can put these x values back into our original function. Our original function was the absolute value of negative 4x plus 2 plus 2. So we can think about this, the absolute value, so we'll start with 0. Negative 4 times 0 is 0. 0 plus 2 is 2. The absolute value of 2 is 2, and then 2 plus 2 is 4. There's a lot of 2's there. Let's go with negative 1. Negative 4 times negative 1 is positive 4. Positive 4 plus 2 is 6. The absolute value of 6 is 6, and then 6 plus 2, that would be 8. Okay? Keep going. Let's try 1. Negative 4 times 1 is negative 4. Negative 4 plus 2 is negative 2. The absolute value of negative 2 is 2, and then 2 plus 2 is 4. Okay, we'll do the same thing with 2. 4 times negative 2 is negative 8. Negative 8 plus 2 is negative 6. The absolute value of negative 6 is positive 6, and then 6 plus 2 is 8. Okay, so we still have that nice symmetry in our table. Now we just have some larger numbers. Let's bring in some graph paper. Let's go ahead and draw our x and y plane here. So there's the y-axis. Now my y values are kind of big, so I'm going to make my x-axis down a little lower. Right down in there. Hopefully I got enough space there. So I'm going to see. I'm gonna plot my vertex last because the 1/2 is going to be a little tricky with the way I'm doing this. So negative 1, positive 8. 1, 2, 3, 4, 5, 6, 7. So positive 8's way up here. So I didn't quite get enough of it, but that's okay. 2, 8 is here. I've got 0, 4 right there. I've also got 1, 4. And then 1/2, 2 is right in there. So our absolute value graph, you know, anytime we shrink it by a fourth, I mean, compared to that one, it got a lot more narrow, and it also flipped sides. So you can see the reflection in the y-axis going from this side to this side, and we're also shoving things a lot closer this way and this way. Okay, so you can see the difference between the two functions. All right, so we've got one more example here to talk about. Let g of x equal the negative 2 times the absolute value of x plus 1 plus 2, and let f of x equal the absolute value of x. Describe the transformation from f to g and graph g of x. Okay, so we've got a lot going on. So this is kind of vertex form. Okay, so we can kind of think about that. We can also, let's describe the transformation from f to g. So we've got a lot going on here. So the x plus 1, okay, we're adding 1 directly to x. So if we're adding directly to x, that is a translation. And it's going to be 1 unit. And if it's plus 1, remember it's backwards, it's horizontal, so it's going to be 1 unit to the left. Okay, so it's a translation, 1 unit left. We're just going to follow the order of operations here. Okay, the next thing is the 2, just the 2, and that's on the outside of the function. Okay, it's not directly to x, so what that means, it's a vertical stretch or shrink, vertical something by a factor. Now, if it's vertical, excuse me, the factor is normal. It's what you see in the function. The factor is 2, and if the factor is bigger than 1, that makes it a vertical stretch. Okay. What else do we have? We have this negative sign out front. The negative, it's not with x. It is on the outside, which means it is even though it's negative, that still means it's a reflection. But we can think of it as a vertical reflection, so it'd be going from top of the graph to bottom of the graph. The line we cross there is the x-axis, so it's a reflection in the x-axis. That's what the negative does. And then the last thing here is the plus 2. The plus 2, it's on the end of the function. It's not directly to x. Anytime we're adding or subtracting, it is a translation. Translation, it's going to be 2 units. And since it's vertical, the directions are normal. This is 2 units up. Okay, so what I'm going to do, I'm going to graph f of x. I'm going to graph the original in black, and then I will graph the new function in, well, let's see, we'll do it in orange. Okay, we'll do this one in orange, and we're going to follow these 4 transformations to get our new graph. Okay, so let's go ahead and do it, because we've described the transformation. We've taken care of that. Now let's go ahead and graph. Let me bring in some graph paper here. Let's go ahead and draw our XY plane. Kind of a bigger one today. Might need some space. Okay, so I'm also going to make an XY table over here. 2, 3, 4. Okay, this is for the original function, -2, -1, 0, 1, and 2. Okay, if I plug in, because remember the original one was the absolute value of x. So all we need to do is find the absolute value of these 5 numbers, and that will give us our y values. Okay, so the absolute value of 0 is 0, the absolute value of 1 is 1, absolute value of 2 is 2, absolute value of -1 is +1, the absolute value of -2 is +2. Okay, so we've got our 5 points. We've got 0, 0, we have -1, 1, we have -2, 2, we have 1, 1, and we have 2, 2. Okay, so here is our original function. Looks like this. Okay, there's the original function. That's f of x. Now, I'm going to take each point individually, and I'm going to follow these 5 steps. Okay, I'm going to make some different. I'm going to mark things in different colors here. So just kind of bear with me. Okay, so I'm going to start with the vertex. I'm going to go 1 unit left, so that would put me there. Okay, then I need to stretch it by a factor of 2 vertically, so that would be farther away from the x-axis. The problem is I'm on the x-axis, so that's not going to change. I'm not going to get any farther away because my distance is already 0. With the reflection, I'm on the x-axis, so if I reflect it over the x-axis, I'm going to stay on the x-axis. So this point's not going to move for the vertical stretch or the reflection. The last thing we need to do is translate it 2 units up. That point is now right here. Okay, so actually I need to make that in orange. Okay, so I'll do this part in orange as well. Everything else I will follow the colors. Okay, so my vertex of the new one is this orange point on the graph. All right, so let's try, let's try 1, 1. Okay, we'll use this point right here. So we'll start with the translation 1 unit left. So that puts me here on the y-axis. Then a vertical stretch by a factor of 2. Okay, so that means I'm 1 away now. So if I'm going to stretch it by a factor of 2, that means I need to be 2 away. Okay, so that's going to be here. So now I'm moving up another one, stretching it out. Reflection in the x-axis. I'm 2 above the x-axis here, so when I reflect it, it's now going to be 2 below the x-axis, so that's there. And then the last thing, a translation 2 units up. So I go 1, 2, and I happen to find myself at the origin. Okay, so that would be, so I've taken care of this one, now I've done this one. So let's go ahead and move this one, the 2, 2. I'm going to start with a translation 1 unit left, so that's over here. And then I need to stretch it by a factor of 2. So I'm 2 away. If I double that, that means I'm going to be 4 away. The next thing I need to do is reflect it in the x-axis. So if I'm 4 above, when I reflect, I'm now going to be 4 below. Okay, so that's right here. And then the last thing to do in orange translation, 2 units up. So that is right here. Okay, so now this one is done. Do the same thing with the other 2. So let's start with -1, 1. So start here. First one is a translation 1 unit to the left. So we'll go 1 over there. There's a lot of colored dots here. The final answer is going to be in orange. Just remember that. The final answer is in orange. Okay? So we've moved it 1 unit left. Now we need to stretch it vertically by a factor of 2. So it was 1 away. So when I stretch it by a factor of 2, it's going to be 2 away. So that'll put me up in here. Okay? Then I need to reflect it in the x-axis. So if I'm 2 above, I need to be 2 below. Okay, so that would put me down in here. And then the last thing is to go 2 units up. So 1, 2 puts me on the x-axis again. So remember, final answer is going to be in orange. The other colors are just following these transformations. The last point we need to do is -2, +2. Okay, so we start with this point right here. We need to go 1 unit to the left, so that's this. Okay, we also need to stretch it by a factor of 2. So if I'm 2 away, if I double that, I'm going to be 4 away, and that's going to be in green. So that's here, so now I'm 4 away. Next thing is to reflect it. So if I'm 4 above, when I reflect, I'm going to be 4 below, so that'll put me down in here. And then the last thing I need to do is translate it 2 units up, so that puts me right there. So the orange one is our final answer. But what I hope you can see here is that if I wanted to, if I wanted to just talk about the translation 1 unit left, I could, if I look at my red dots, I've done that. I've already translated 1 unit left. If I want to add the vertical stretch by a factor of 2, now it's a little taller. If I want to reflect it, now it's pointing downward. And then when I translate it 2 units up, I just slide everything up. Okay, so if you want, you could draw all of these graphs. You could show every transformation. We've talked about a translation, that's in red. We've talked about a vertical stretch, that's in green. We've talked about a reflection, that's the one in blue. And then the last one's a translation 2 units up. That's what we did in orange. So we can have lots of different colors, we can have lots of different lines, but every different color represents a specific transformation. And if we combine them all, we end up with the orange one. So the orange one is your final answer. That is the graph of g of x after we do all 4 of these transformations. The key here is just going slow, making sure we're doing everything in a systematic way, and not trying to skip steps or do more than one step at a time, because that's when people tend to get lost and make mistakes.